So we're going to use ratio table or proportions and find the side length in a triangle, a right triangle where an altitude is drawn. So when we draw an altitude in a right triangle, we create three similar right triangles. And let's see why that happens. So I'm going to draw an altitude. So I'm going to draw my altitude from C perpendicular to the opposite side, hypothetically. You're going to see how that looks. And here is pointy. All right, so I have created three right triangles. Each of the triangles that I have created, each has a right or 90-degree angle in it. Okay, so now I'm going to hypothetically, making this up, okay, I'm going to say that this angle here is 30 degrees, and that would make the other angle 60 degrees, because in a triangle, the angles have to sum to 180. I already have a 90-degree angle, so the other two angles must measure 90 when added together. So if this portion is 30, this other portion is 60. And I've marked the 60-degree angle, the middle-sized angle with two dashes, and the smaller angle with a single dash. So if I look at this bigger triangle now, I have a right angle, I have a 60-degree angle, which would mean that this angle down here at angle B would also be 30 degrees. So similar triangles have equal corresponding angles. So the parts of these triangles, these three triangles that correspond, have equal angles. So by angle, I know that these three triangles are similar to each other. And so if I want to use that information to find the length of a side, then I also know that similar triangles have proportional corresponding sides. So I can set up a ratio of corresponding sides and use that to solve for one of them. All right, let's put this into practice here. So I've drawn a table, and it has the smallest side, the middle side, and the hypotenuse, which is the largest side. Before starting this question, I would mark all the angles with a single dash and a double dash. I would label my little right angle there. And so I can use that double dash and single dash. Each triangle only has a double and a single and a right angle to help me organize the sides. I can also think of them as small, middle, and longest side, where the hypotenuse is the longest side. And I'm going to be comparing three different triangles here. I have the small, the middle, and the large triangle. So it says find the length of CH. I'm going to represent that with X. If AH is 12, AH is 12, and BH is 16. So CH I have represented with X here. Okay, so if I'm thinking of corresponding sides in the smallest triangle, so I could take my hand and physically cover up the middle triangle here. And so my smallest side would be X. My middle side would be 12, and I don't know the hypotenuse, so I would leave that blank. So now I'm going to look at the middle triangle. I would take my hand and physically cover up the smaller one, and so I would look at the dimensions there. Okay, the smallest side or opposite that single dash is 12. Opposite the double angle is 16. I don't know my hypotenuse either. And if we think about the bigger triangle, the only thing I know about that is if I add x plus 16, that would be the length of my hypotenuse here. Okay, I need a row and a column, a pair of row and columns to go together, and so I'm going to use this pair here. This gives me my proportion that I will now solve through cross multiplication to get that missing side CH, which is x. It's what I set x equal to at the beginning of the problem. So if I want x by itself, I would multiply both sides by 12, and that is going to leave me to 9. So CH is 9.